In Python, a variable is a name that represents a value in the computer's memory. We say a variable references the value in memory. As an example, if I do a simple line of a equals sign 1, a now references the value 1. We can also say that line assigns 1 to a. When it comes to a line like a equals sign 1 and anything taking that form, the value on the right is assigned to the variable on the left. Meaning if we swap that line and did 1 equals a, we'd get an error. This is because now you're asserting 1 is a variable and that a, before you've assigned any value to it, has a value. Both of those assertions are nonsense, which is why you get the error if you try to flip the order. Variables cannot be used until they're assigned a value. This is why typos can be a huge pain in the butt. Say you had this code here, where you assign 5 to ball, then you print out ball. You've done all your logic right, but because you misspelled ball when you print it out, you'll get a name error that BAL isn't defined. Oftentimes, you'll get so caught up in trying to look for your mistake in higher level logic that you'll look right past the fact that you might have misspelled a variable name. Python has a set of variable name rules that you must follow. Python variable names can't be keywords, so you can't name your variables things like for, while, if, or else. You can't have any spaces or non-underscore symbols in your variable names. A variable must start with a letter or underscore. After the first character, letters, numbers, and underscores are all allowed. Finally, variable names are case sensitive, meaning hi there, all lowercase, and hi there, where you capitalize the T in there, are different variables. One example to review these rules. Underscore base 3 is a perfectly valid variable name. It starts with an underscore and has a number outside the first character, so no rule has been broken. 3 base underscore, though, is an invalid variable name. The name starts with a number, so it breaks one of the rules. Now to put the variable in variable. If we assign 1 to a, then in the next line we assign 2 to a changes from referencing 1 to referencing 2, so variables change by changing what they reference. Another point, Python variables are dynamically typed, so they can hold any value. Assigning 1 to a, then assigning the string hi to a on the next line is totally valid because Python variables aren't regulated to holding only one type throughout their existence. In Python, as well as other languages, comments are notes to yourself and others about what the code is doing. One of the worst things when you're coding is break-induced code amnesia. You come back to code you wrote a long time ago and you have no clue what the code is doing. Good comments go a long way to helping with this. Here's a bad example of commenting. Try to see if you know where the commenting goes wrong as I do it. So you're printing out every number in the list. Nums is a list of numbers from 1 through 5. So it's a list of numbers. Then if you're printing every number, you must loop through every number. So for num and nums. Then our goal here is to print the numbers. So we print each number. You probably caught where I veered heavily into bad commenting practices, but I'll go straight into achieving the same result, but with good commenting. You have a function called printNumbers that takes in an argument called nums. It prints out every number in nums. So for num and nums. The big takeaway here is that comments should be describing why, or the intention of code, not focusing on each microscopic level of detail that happens on every line of code. Also, variable names and function names can do a lot of heavy lifting for you, so you don't have to write nearly as many comments. In naming a function, print numbers, you limit 80 to 90% of doubts over what the function does, and you never once wrote a comment. Now that we've gone over the best ways to use comments, what types of comments are available to you? There's 2 main comments, single and multi-line comments. Single-line comments, as you've already seen, are lines preceded by a hashtag. The 2 places you can put them are before a line of code, meaning the line above, or directly horizontally after the line of code. General good Python style recommends not going past column 80 in your code, so I find myself using before line single line comments more often. Multi-line comments are further separated into 2 categories, comments on multiple lines and docstrings. Comments on multiple lines are exactly what they sound like. Instead of the hashtag where your comment can only cover 1 line, now it covers many lines. Now for docstrings. Remember this print numbers function from before? These lines 2 through 5 are no ordinary multi-line comment. If you call the help function and pass in this function, the output will be the function header itself. So the name of the function and the fact that it takes in an argument called nums, In addition to that, help will also output anything you write in this multi-line comment right at the start of the function. That's why it's called a doc string. It's a string that helps you document your code. If you want this doc string to be even more helpful, you can add things in like the types of the parameters, what their purpose is in the function, and any values you might be returning. Of course, in this case, since we're just printing a list out, we're returning nothing. Today you're going to learn about the print function in Python, but first, if you're trying to learn to code, hit that subscribe button for daily beginner-friendly coding videos. The print function prints text to the screen. Bet you didn't expect that one. It also converts its arguments to strings if they are not already. Also, you can pass multiple arguments into print and they will all get printed out. The sep optional parameter is a character or characters you can specify to separate multiple arguments passed to the print function. By default, sep is a space. This code ends up printing 1,000,000, comma separated. The end optional parameter is a character or characters you can specify to end the printout with. By default, end is the new line character. This code ends up printing hi. If you only specify end and nothing else, that's all the print function prints. This code will just print the exclamation point. What is a string literal in Python? Let's break that down. First, what's a string? Let's give ourselves a variable s1 that equals double quotes hello. Since s1 is holding a sequence of characters, it is a string. Okay, so what's the literal part? The literal part is when a string appears directly in your code, like the hello of s1. But there are two other ways to write string literals in Python. s2 equals single quotes world. World is now also a string literal. Last, you can use triple double quotes. s3 equals triple quotes subscribe. Triple quotes. All of these strings on the right side of the equals sign are string literals. Variable assignment in Python creates a variable and makes it reference a piece of data. Well then, what's a variable? A variable is a name that represents a value in the computer. We have a code editor in front of us. Let's do an assignment statement. X equals 5. This assignment statement has two parts, or steps. First, the variable x is created. Then, x references the value 5. This can be generalized. Any assignment statement can be written as variable equals expression. The right-hand side, or the expression side, evaluates to a value before the variable references it. For instance, we can make variable equal 1 plus 2 plus 3. This won't give you any kind of error. It will simply compute the sum to be 6, then store that value in variable. Another thing of note, this order of variable equals expression cannot be flipped. You actually get an error if you try to flip it, and I'll link a video delving deeper into that error down below. Also, a variable must have an assigned value before being used. In a little bit of a look ahead, we can do something like x equals x plus 5. This normally says take the value that x references and add 5 to it. This code, exactly as written though, will give you an error. That is because you didn't assign x a value before incrementing it by 5. This last part is a bit of a higher level concept if you're already familiar with programming. Feel free to listen on, but if you don't understand it all, don't worry. This whole video, we were talking about variables referencing values. What's that about? Many other languages, like Java or C for example, you can do in x equals 5. And you would say that the variable x holds 5. As it turns out, in languages like Java and C, the variable's value is stored in the variable's memory location for the most part. In Python and other languages, the variable holds the memory address of the value. So we say the variable references the value. I went to college for this stuff, but never really liked the term reference. So I had this little mental picture so you remember what exactly is going on with reference. Imagine you were watching a movie. Let's say Star Wars. No funny business. This movie is like C and Java in our example. The movie holds Star Wars. Now imagine you're watching a TV show. It's not Star Wars, it's something else. Totally different. But the show references Star Wars. That's the way the concept of variable reference is going on. Star Wars is nowhere in this TV show, but however it is presented, they mention something in such a way that ties back to Star Wars. That is the way I like to think about variable reference. The Python data types for beginners that we will cover today are ints, floats, and strings. What's a data type? A data type is a set of values and the set of allowed operations on those values. First, we'll cover the numeric data types. If a variable has no fractional part, then it is an int. For example, x equals 5. X is an int variable. If a variable has a fractional part, then it is a float. For example, pi equals 3.14. Pi is a float variable. When you write a number directly in your code, that is the numeric literal. When you assign a value to a variable in Python, how does Python determine if it is an int or a float? If you have a numeric literal that is a whole number with no decimal point, then Python knows that is an integer. In contrast, if you have a numeric literal with a decimal point, then Python knows that is a float. If you yourself are not sure of the type of the variable, how can you check? There's a function for that. We can do x equals 5, then print type of x. Type tells us the type of the variable. If we run the code, you'll see that x is an int. Let's make some new variables. X equals $350, y equals 1,000, known more commonly as 1,000. What do you think these two assignment statements have in common? It turns out both of them are invalid. Numeric literals cannot have currency signs in them or commas. Last, we'll cover strings. A string is a sequence of characters. We've covered numeric literals in this video. I've already covered string literals in a different video that I'll link down below. Let's give ourselves a string. S equals hello. What did I mean before about sequence? It turns out Python strings have a sense of order, meaning you can get the first character in the string. To do that, you would do S square brackets 0. Programming is a bit weird. When you want to get the first item in a container, you use the number 0. There's a reason for that, but it's beyond the scope of this video. Anyways, this expression, S square bracket 0, would evaluate to the first character in S, that being the character H. Notably, if you're familiar with other programming languages, Python doesn't have a dedicated character type. One character is just a string of length 1. In Python, integer division works by doing division, but not keeping the fractional part. Let's start off by doing a simple one. Print 3 double division bar 2. If this was regular division with just one division bar, you know the answer would be 1.5. Let's run the code and see what the answer is. 1. From that you can see that integer division, where the answer is positive, just truncates or cuts off the fractional part. What happens if the answer is negative though? Let's do print -1 double division bar 3. The non-integer division answer to this is -1/3. So one might think the answer is just 0. Let's run the code. Turns out, no. Integer division, where the answer is negative, always rounds down. Meaning, although 0 is certainly closer to -1/3 than -1, -1/3 rounds down to -1. So it is the answer. In Python, operator precedence is basically identical to the order of operations you learned in grade school. Let's do an example or two to refresh in your mind how it works. Print 5 plus 3 times 5. This does the multiplication first, then the addition. So 15 plus 5 equals 20. If we run the code, we'll see our answer is correct. Now for a new example, print 2 times 3 times 5. If you haven't watched my previous video I did on Python arithmetic operators, I'll link it down below. The double multiplication sign is exponentiation. So if we work out the math, 2 to the 3rd power is 8 times 5 equals 40. If we run the code, we were right. Operator associativity determines the order the same operator gets evaluated in Python. For almost all the math operators, they are left to right associative, meaning if we do print 1 minus 2 minus 3, that evaluates left to right, and the answer would be -4. If we run that code, you'll see we're correct. The one math operator that is not left to right associative is the exponent operator. If we do print 2 times 3 times 2, that actually evaluates 3 to the 2nd, or 9, first. Then it does 2 to the 9th to get 512. It does not, in fact, do 2 to the 3rd, get 8, then do 8 squared. If we run the code, you'll see we're right. In Python, the arithmetic operators are the operators that do math with numbers. Let's start off with addition. Print 1 plus 3. If we run the code, you'll see 1 plus 3 is 4. Nothing too fancy about this. Next, subtraction. Print 4 minus 3. If we run the code, you'll see 4 minus 3 is 1. Nothing too fancy about subtraction either. Next, multiplication. Print 2 times 3. If we run the code, you'll see 2 times 3 is 6. Still nothing fancy. Now we'll get into the slightly fancy, the remainder or modulo operator represented by the percent sign. We can do print 3 modulo 2. Based on what you know about division, if you do 3 divided by 2, the remainder you get is 1. So we should expect the answer to be 1. If we run the code, you'll see our expectation is right. Next, Python actually has a built-in exponentiation operator represented by the multiplication operator twice. If we do print 2 times 3, this does 2 to the third power. If we run this code, you'll see 2 to the third power is 8. Last, the first flavor of division. If we do print 1 divided by 2, and run the code, you'll see 1 divided by 2 is 0.5. In Python, the modulo operator evaluates the remainder of a division problem. Someone can and probably will actually me in the comments, but I don't think there's any practical use for negative numbers with the modulo operator. So let's walk through a couple of examples with positive integers. Print 4 modulo 3. The remainder of 4 divided by 3 is 1, so if we run this code, we'll see we're correct, and the answer is 1. Next, let's use the modulo operator to check if a number is even. Print 6 mod 2. If the answer we get is 0, then we know 6 is even. If we run the code, we'll see 6 is indeed even. In Python, string concatenation is the act of joining two strings together. To be exact, concatenation is defined as joining one string to the end of another string. Let's work out an example. Str1 equals string hello space. Str2 equals string world. S equals str1 plus str2. The plus sign is the main way to concatenate two strings in Python. If we print s, then run the code, we'll see hello world. As a brief, interesting Easter egg, you can do concatenation without the plus sign at all, but generally I would caution against using this because Python's main shtick is explicit is better than implicit. Let's show it as an example. S equals string hello space, then string world right next to the hello string on the same line. If we print s and run the code, we'll see it works identically to using the plus sign. In Python, escape characters are special characters starting with a backslash inside a string literal. These characters act as special commands when printed. Showing's better than telling. If we print hello \n world, then run the code, we'll see the \n prints a new line. If we print hi \t there, then run the code, we'll see the \t prints a tab. If we print single quote, then run the code, we'll see a single quote literal. If we print double quote, then run the code, we'll see a double quote literal. Last, if we print \\, then run the code, we'll see a \/ literal. In Python, an if statement runs some code if a condition is true. In the next video, we'll go through in greater depth how the condition works. We'll walk through two examples. Num equals 3. If num mod 2 doesn't equal 0, then print odd. Outside the if, print num. This code reads, if the number isn't even, then print odd. If we run the code, we'll see num is odd. For our next example, num equals 4. If num mod 2 equals 0, colon, then print even. Outside the if, print num. This code reads, if the number is even, then print even. If we run the code, we'll see num is even. So at its most basic, an if statement is simply, if a condition is true, then run some code. Otherwise, continue to run code after the if statement. We saw this as regardless of whether num was odd or even, num was still printed afterwards, as that print was after the if altogether. In Python, logical operators are used to join Boolean values together in more complex ways than just true or false. The most basic logical operator is not. Not true is false. Not false is true. You can also be really stupid with it and tack on as many nots as you want. Basically, an odd number of nots will result in the opposite Boolean value, and an even number of nots will result in the same Boolean value. As an example, not true is true. Another logical operator is and. And only ultimately results in true if every Boolean you're joined together is true. You can do two trues, but if you and on a false to the end of it, the final result ends up being false. Another logical operator is or. The only way it ultimately results in false is if every Boolean you're joined together is false. As long as there's one true, the final result is true. Like math operators, logical operators have a precedence on what operator gets evaluated first. In true or false, and has a higher precedence than or, so false and false gets calculated to be false. Then, true or false gets calculated to be true. If you simply did left to right here, you would incorrectly get that this expression results in false. In Python, Boolean expressions are pieces of code that evaluate to true or false. These come in two main categories, relational operators and logical operators. Let's do an example of each one. Print 2 greater than 1. This is a Boolean expression that evaluates to true because 2 is greater than 1. Next, for a logical operator, print true and false. This evaluates to false because both operators must be true for a logical and expression to be true. In Python, an if-else statement runs some code if a condition is true. Then, some different code is run if the condition is false. Let's do two examples. Num equals 3. Let's print even if the number is even and odd otherwise. So, if num mod 2 equals 0, colon, print even. Else, colon, print odd. I've done a video on the modulo operator before. I'll link that down below. If we run this code, we'll see it prints odd, but not even. That is because the condition of num mod 2 equaling 0 was false, so the code in the else branch ran. For another example, throw back to middle school math. Num equals -1 times -1. If num greater than or equal to 0, colon, print positive. Else, colon, print negative. If you remember from middle school, a negative times a negative equals a positive. And if we run the code, you'll see it is indeed positive. Since the condition was true, the if branch ran. Nested if statements in Python extend the concept of the if statement and allow for testing multiple conditions. For our two examples today, we'll revisit some good old grade school math. Numbers are considered either positive, negative, or 0, so let's write some code that tests that. Num equals 0. If num greater than or equal to 0, meaning it is either positive or 0, then we will nest another if statement. If num equals 0, then we'll print 0. Else print positive. One level back out, else print negative. So if we run this code, we'll see num is 0. For our next example, we'll categorize 3 different types of triangles. If all 3 sides are equal, that is an equilateral triangle. If only 2 sides are equal, that is an isosceles triangle. Last, no equal side means a scalene triangle. For the code, we'll start with equal sides equals 2. If equal sides greater than or equal to 2, then we'll nest. If equal sides equals 2, then we'll print isos. Else, meaning the triangle has 3 equal sides, we'll print equal. One level back out, else, print scale. So, if we run this code, we'll see the given triangle is isosceles because it has 2 equal sides. In Python, if, elif, and else further extend the concept of the if statement by allowing for testing of multiple non-overlapping conditions. For instance, a number is either positive, negative, or 0. A number cannot fall into more than one of those categories at once. Let's write some code. Num equals 3. If num equals 0, then print 0. Elif num greater than or equal to 0, print positive. Else, print negative. If we run this code, we'll see num is positive. Now for the next example, we'll do a fairly standard grading scale. Grade equals 100. If grade greater than or equal to 90, then print A. Elif grade greater than or equal to 80, then print B. Elif grade greater than or equal to 70, then print C. Elif grade greater than or equal to 60, then print D. Else, print F. If we run this code, we'll see our grade is an A. One final note, why is the elif even needed? Can't we just stack ifs? Let's answer by showing. We'll change all the elifs to if and see what happens. If we run this code, we'll see we got a 100 and our grade is A and B and C and D. Obviously, for practical reasons, that's nonsense. Your grade is one thing and it can't be more than one thing. It turns out with elif, a condition being true means you run the code under that specific condition, then jump to the end of the conditional ladder. Just stacking ifs, on the other hand, doesn't do that. Every time a condition is true, regardless of previous conditions being true, the code in the true conditions branch runs. In Python, a match case statement is superficially similar to a switch case statement in other languages. For our main example today, we'll be talking about Internet Files media types. You don't have to know what that means other than the web interprets different types of files in different ways. To start, we'll use the input function to prompt the user to enter a file name. So fname equals input of file name :space dot lower to normalize the inputs with uppercase letters. Next, and for this step, we'll presume we don't have to worry about files with no dots. We'll split on the dot character. So fname equals fname dot split of dot character. This splits the string into the pieces that occur around the dot character. Now we'll start with the superficially similar example and consider just PDF, text, and PNG file extensions. we'll do match on the last element of the fname list. So match fname sub -1. Now, the cases will be pure equality checks. Case PDF colon print application / PDF. Case text colon print text / plain. Case PNG colon print image / PNG. If you're at all familiar with switch case in other languages, this is correct syntax, as there's no need for break statements at the end of each case, as if a case runs, then code continues after the end of the match case statement. A good default for our purposes would be application / octet string. To do a default case, just do case _ Then we'll print application / octet stream. I keep saying superficially. Other than the no fall through I mentioned before, how else does Python match case differ? For one thing, we use the string PDF in the case and then also print the identical string in the printout. The same with PNG. This seems like we could deduplicate the string somehow. It turns out Python's match case statement does have this feature. We can write as app after the PDF case and as img after the PNG case. This assigns the given string value to the variable on its same line, so assigns PDF to app or PNG to img, which is now a variable you can use inside the case, which we can use fstrings now to deduplicate the strings. Under PDF we can do fstring application / curly braces app. Under PNG we can do fstring image / curly braces img. This is all fine and good, but what if we want to handle other media types or blank file names? It turns out the Python match case has a fancier name in its official documentation: structural pattern matching. We don't have to match based on what data equals. Match case allows us to match based on what data is shaped like. So, we can match on the entire split list itself, meaning change the match to just fname. Then, if we want to match on a list that's a result of the entry string being empty, you have to know a little about split. Splitting on an empty string just gives you a list with a single empty string. So our first case can be case list with empty string. And inside, print nothing entered. Continue on with this idea of what data is shaped like. Let's modify the rest of the existing code. For a string that represents a PDF file, you would want a list with anything as the first element, then the string PDF as the second element, and you can keep the as around to simplify the printing. You can use underscore as a wildcard to represent any element, so you can modify this line by wrapping it in list braces, then do underscore, comma. This now matches on the split list. We can modify the text in PNG lines similarly. It turns out different image file extensions often default to the similar media type pattern of image / the file extension of the image. Python's match case has another feature where you can give a case multiple different options. So let's add GIF and JPEG to this code. We can just wrap PNG in parentheses, then do vertical bar to signify or, and yes, you must use a vertical bar, you cannot alternatively use or, GIF vertical bar JPEG with an E. To read this case out, it says match a list that starts with one element of anything, and then its second element is either the string PNG or GIF or JPEG. But what if you wanted to handle a stupid file with multiple extensions, something like a.wav.text.pdf, and only cared about what the last dot was? Match case even has an answer for that. Just prepend a star to the underscore in your match. They basically now say, take a list with any amount of anything at the start, and then be concerned with what the last element of the list is. By script length alone, I know this will already be a long video, but there's one more concept of match case statements to know, that being guard clauses. For that, though, let's do a different example. We're going to check if a number is positive, negative, or 0 based on input from the user, but we will also do error checking on the input. So first we'll get a number from the user. Num equals input of string, please enter a number, space, dot strip, to make sure leading and trailing white space is removed from the user's input. We can do match num : but then we immediately run into a problem. The case itself cannot be an expression that calculates a value, meaning something as simple as addition or as complicated as a function call. We could just at the top convert num in the match to an int, but then any input that couldn't convert to an integer would automatically raise a value error. In come guard clauses, which allows match case statements to further filter inputs. We'll start with the case of the input string being 0. Case n to start. The official documentation and tutorials on this want to jargon you till the cows come home and say capture this and bind that. Let me be plainly clear. This n stores the value you are pattern matching on in the variable n and lets you further work on it with guard clauses in a way that a plain case would not allow. To go further on the 0 case and do the guard clause, if n dot is digit. The guard clause works similar to a regular if statement. Run this case branch if the guard clause is true. As written currently, this is incomplete though. This will match on any input string that looks like a positive integer. So we'll add and int of n equals 0. This works identical to the short circuiting of and in a regular if statement. If every character in the input string is not a digit, meaning the first clause evaluated to false, the integer conversion is never ran from the second clause. Inside the case, we can simply print 0. The next case will be much simpler to explain. We've handled 0 already, so case n, if n dot is digit, print positive. If every character in the input string is a digit, and we don't already classify it as a 0, then we know it must be positive as isDigit does not accept the negative sign as a valid character. Last, negatives. We want to know that the first character is the negative sign, and the rest are valid digits. So, case n, if n dot starts with the negative sign, and n starting at index 1, meaning the second character, and onwards, dot is digit, then print negative. For our default case, handling floats would make this already long video even longer, so if we've reached this case, the input is either a float or not a valid number. So case underscore print either a float or not a number. That, at long last, is everything there is to know about match case statements in Python. In Python, the Walrus operator takes assignment and changes it from a statement to an expression. What is an expression? An expression, by Python definition, is a piece of code that evaluates to a value. For example, abs of -5. That is a piece of code that evaluates to 5. Or just 5 plus 5. That is a piece of code that evaluates to 10. So what is a statement? A statement, strictly, does a thing and does not evaluate to a value. Let's show this off with printing. If we were to do print x equals 5, this plain would not work, as for the most part, Python can only print expressions, and regular assignment is a statement. If, however, we change this assignment to $sign, known as the Walrus operator or alternatively as an assignment expression, then ran this code, print would work fine in print 5. A key thing happens on the line with the Walrus operator now. On the same line, Python assigns 5 to the variable x, as well as the assignment expression itself evaluating to the value 5, which is the value that print prints out. Understanding how it works is well and good, but let's also show you a practical example. First, let's write out the Fibonacci function. Understanding what this is or how it works isn't necessary, it's just a function that takes a bit of time to run. Let's say we're wanting to see if Fibonacci of 35 is greater than 10,000. So if fib of 35 greater than 10,000, then print fib of 35. If we run this code, we will see it takes approximately 5 console cursor flashes to run. But, given the topic of this video, we can make this code run faster. We can change this to be if parentheses res walrus fib of 35 parentheses, then inside the if we can just print res. This line works because the Walrus operator makes the line evaluate to a value, but also assigns a value to the res variable that we use inside the if to later print the value out. If we run this code, we'll see now that it only takes 3 cursor flashes to run. So, by no means official timing, but you just made the code faster. In Python, the ternary operator is a shorthand if-else expression, meaning it evaluates to a value. Optionally, you may hear it referred to as a conditional statement. The syntax for the ternary operator in Python is the following: val if true, if cond else, val if false. Meaning, this expression evaluates to val if true if the condition is true, and false otherwise. Well, let's give a concrete example. We'll find the sign of a number, x equals 5. X underscore sign equals pos if x greater than or equal to 0, else neg. After that, we'll print x sign. If we run this code, you'll see x's sign is pos. If you were to change this to -5, you'd see it print out neg, but I'm sure you already trust math. This isn't relegated to purely assignment. We can also use it in functions to return a value. Def is odd takes in a num. In practice, you'd probably write the function the following way: return num mod 2 equals 1. You do it this way because then if the number is odd, it returns true, otherwise it returns false. For the sake of illustrating the tool though, let's use a ternary operator. Return true if num mod 2 equals 1, else false. This uses the ternary operator to correctly express the is-odd function. In Python, a for loop runs some code a certain amount of times. Let's do an example. For val in parentheses 1, 2, and 3. Print val. The way the for loops work is, on the first run of the loop, val is assigned the value of 1, then the code inside the for loop is ran, meaning 1 gets printed. Finally, val is assigned the next item in the sequence, and the process repeats itself. If we run this code, we'll see 1, 2, and 3 printed. The previous video was about while loops, so what is the difference between for and while loop in Python? The main difference is that you know how many times the for loop will run. You know this code will always loop through the 3 numbers. While loops, on the other hand, only end once the condition becomes false. You don't know in advance how many runs of the loop that will take. For the next example, what if we had an irrational hatred of the number 2, so we just wanted to end the for loop once it reached 2? We could simply go into the for loop and write if val equals 2, break. This ends the for loop once val becomes 2. There's another way to do a for loop where you don't need to list out all the elements you want to loop over. Say you wanted to print the numbers 1 through 10. You could write for val in range 1, 10 plus 1. print val. Range is a Python function that creates a sequence of numbers. The first argument is the first number in the sequence. The second argument answers the question of, is range in Python inclusive or exclusive? The second number in range is the first number to exclude in the sequence of numbers, meaning range is exclusive of the second number you pass to range. That's why I like to do the +1, because I feel that's more explicit of the numbers I'm intending to loop through. I keep saying second and not last because you can optionally pass a third argument to range. This is the amount that range increments the sequence by each time. By default, range increments the sequence by 1 each time. If we run this code, we'll see it prints out 1 through 10. One last thing for a little fun. We covered in the while loop how to do an infinite loop. How do you make an infinite for loop in Python? Turns out you can import the count function from the itertools library to do this. The point of this video isn't to illustrate how this function works, but you can simply write from itertools import count for val in count parentheses print val. This for loop would go on forever. In Python, a while loop runs some code until a condition is false. Let's do some examples. For this one, we'll find the first vowel in a string. S equals snipe. Cur equals S sub 0. I equals 0. While cur not in string AEIOUY, meaning while the current character is not one of A or E or I or U or Y, then continue to loop. Inside the loop, do I plus equals 1. Then cur equals the next character in the string, so cur equals S sub I. Meaning one entire run of the loop works like this. Check if cur is a vowel. If it is not a vowel, then run the loop. Add 1 to I, then update cur, then rinse and repeat. This means while is a precondition loop because the condition is checked before each iteration of the loop runs. Outside of the loop, print cur. If we run this code, you'll see the first vowel in snipe is I. Next, we'll show how to do an infinite loop in Python. Infinite loops are loops that never end because their condition never becomes false. For this example, num equals 0, while true, num plus equals 1, print num. True is always true, so this loop simply goes on forever. To end this infinite loop, you can add in a break statement. If num greater than or equal to 10, then break. This means once num becomes greater than or equal to 10, break leaves the loop and supersedes the fact that the condition has yet to become false. Last, we'll show how to stop a regular loop. I equals 0, while I less than or equal to 10, print I plus equals 1. If I equals 2, then break. So, this loop automatically ends once I becomes 2 because of the break statement. In Python, augmented assignment operators do a combination of performing an operation on a variable and assigning said result back to the same variable. Let's do 2 examples to illustrate the 2 main ones. X equals 5. Let's say we wanted to add 1 to x. We could do x equals x plus 1. This is completely valid code and nothing is wrong with it. Alternatively, though, you could use an augmented assignment operator. To use the augmented assignment operator, you would rewrite this line as x plus equals 1. You'd read this line as add 1 to x and assign the result back to x. Next, subtraction. Let's say we want to subtract 1 from x. The first way you might think up is to do x equals x minus 1. Like before, this is a valid line. To do it with an augmented assignment operator, you could do x minus equals 1. You read this like subtract 1 from x and assign that result back to x. Python has augmented assignment operators for all the other arithmetic operators, but they work identically to what I just showed you with addition and subtraction. In Python, nested loops are loops inside of other loops. Let's make a nested loop. For I in range 3, for j in range 3, print I comma j. For the outer loop, where I is the counter every time it runs once, the inner loop, where j is the counter, runs 3 times. It's best to think of nested loops like an n-dimensional grid. Right here, we've written a 2D loop, so we'll imagine it like a 2D grid. Here on the left, you'll see the 2D grid, where I is the row and j is the column. The printout starts where I is 0 and j is 0, so the top left in this grid. After that, the inner loop continues to run, so j gets printed out as 1, then 2. Then, the inner loop is done for this run, so the outer loop increments by 1, and then the process repeats itself. So, I being 1 and j being 0 gets printed, and the loop continues like this. One thing of note, a new loop doesn't give the variable a new scope, so you shouldn't make both of these counters I, as the outer loop modifying I would be retained in the inner loop. Last, what if you just had an irrational fear of the number 2 and you didn't want that number printed? You could, in the inner loop, do if j equals 2, break. This breaks out of the inner loop if j equals 2 and allows the outer loop to go to the next iteration. If we run this code, we'll see j being 2 is skipped. The Python break statement breaks out of a loop. For example, let's do for I in range 10. And we want to tell the young folks to get off of our lawn and not let the code print the number 6 or the one after 6. So we do if I equals 6, break. After that, just print I. If we run this code, we'll see the printing stopped after the number 5, which is exactly how the Python break statement works. This gets a bit more interesting if you consider nested loops, though, as the break statement only breaks out of the innermost loop. Let's change this up and do for I in range 10, for j in range 10, print I and j. Let's say this time we don't like the number 3, so if either counter reaches 3, we break out of both loop. The best way to do this is with a flag variable. Outside of both loops, break outer equals false. Inside the inner loop, before the print, because that's how much we don't like 3, we'll check if either of I or j are 3. If I equals 3, or j equals 3, then we'll set break outer to true, then break from the inner loop. Last, outside the inner loop, but still in the outer loop, do if break outer, then break. If we run this code, you'll see we've effectively used the Python break statement and broken out of both loops, as 3 is never printed. The Python continue statement skips to the next run of a loop. For example, let's do for I in range 10. Inside the loop, print I. Today, we don't like the number 7, so we want to skip printing out 7. Before the print, we can do if I equals 7, continue. If we run this code, we'll see the printout skipped 7, which is exactly how the Python continue statement works. This poses an interesting question. If we erase the code inside of the for loop and add an inner for loop of for j in range 10, how does continue work in nested loops in Python? If inside the inner loop we did if j equals 7, then continue, then after that did print j. The continue would only skip the number 7 in the inner loop. It does nothing to affect the outer loop. How to create a list in Python. A list consists of a few different things. It should be enclosed in square brackets and have its values separated by commas. The values in the list are in order, with the first element occurring in index 0. So you can create a list A by doing A equals square brackets 1, 2, 3. How to create an empty list in Python. There are two different ways to create an empty list in Python. The first way is to do A equals empty square brackets. This stores an empty list in the variable A. The other way is to do B equals the list constructor with nothing passed to it. This stores an empty list in the variable B. How to slice a list in Python. Let's start out with a list A that has 1, 2, 3, and 4. Let's start out with just a start value. We will print A starting at index 1 and going to the end of the list. What I just described is what it will print out. It will give you a list that starts at index 1, or the number 2, on to the end of the list. If we run the code, you'll see it prints a list containing 2, 3, and 4, just like I said. Next, let's give a start and stop value. We will print A starting at index 1 and ending at index 3. The way this works is a bit of a misnomer compared to what I just said. It still gives you a list starting at index 1, but it goes up to, but not including, index 3. So that stop value is 1 less than the index slice stops at. If we run the code, you'll see it prints a list containing 2 and 3, like we expected. Now for one last example, we will have a start, stop, and step value. We will print A with simply a step value of -1. This slice starts at the end of the list, then steps towards the front. If we run this code, you'll see it prints a list containing 4 through 1, like we expected. How to create an empty tuple in Python is to use a tuple constructor and pass nothing into it. So, t1 equals calling the tuple constructor without any argument. How to create a tuple in Python. You know tuples, you love them. They're ordered, unchangeable collections of items that can be different types. T1 equals a tuple containing 1, 2, 3. How to unpack a tuple in Python. First, what does it mean to unpack a tuple? To unpack a tuple means to put the values in a tuple into separate variables. To unpack a tuple can be done in a single line. Say we have this tuple T1 that holds 1, 2, and 3. To unpack T1, we just write a line like x, y, z equals T1. What this line does is stores the first value of T1 into the variable x, the second value of T1 into y, and the third value of T1 into z. That is how to unpack a tuple in Python. In Python, a set is an unordered collection of items without duplicates. Let's show some examples to explain what I just said. Let's create an empty set. A equals, critically, it's not empty curly braces. Empty curly braces would create an empty dictionary. To create an empty set, you just call the set constructor with no arguments. Okay, I said a set was unordered. What does that mean? If we do A equals a set with 1, 2, and 3, then A sub 0, this would actually trigger an error. Sets don't have any concept of order, so you cannot subscript into them like you would a list. I also said a set has no duplicates. What does that look like? If we do A equals a set with 1, 2, 2, and 3, then print A, len of A, and run the code, you'll see the set A printed, and that it only has a length of 3. This is because Python removed the duplicate 2 as one of the steps when constructing the set. One of a set's desirable operations is membership testing, meaning, is a given value in this set? This operation is constant time on a set, meaning no matter how big the set gets, the time it takes to find a given element stays the same. This is in contrast to a list where the time to find a given element grows with the size of the list. Let's do a quick membership test. A equals a set with 1, 2, and 3. Print 1 in A. If we run this code, we'll see true because 1 is in A. This has been Jacobication. Like and subscribe to learn more.